Okay, this is my third time at FDIM. I have to come from Bishkek in Kyrgyzstan, so it's a bit longer than some of you chaps who come from the next state, or even Hans, who comes from Turkey. I'm going to be talking on operating techniques, basically. It's called stealth operations from hotel rooms and other unlikely locations, QTHs, on MFLF and VLF. It's a development on last year's presentation, which was just stealth operations from hotel rooms and other unlikely QTHs. And because this was put in last year's proceedings, I had to change it slightly. One of the reasons that I do this is because I travel an awful lot. I worked for the UN from about 1995 and went to Cambodia, South Africa, Mozambique, Bosnia, Iraq, Western Sahara, East Timor, Kyrgyzstan, Afghanistan, Somalia, Pakistan, and back to Kyrgyzstan. So I've been in quite a few interesting places, and I've also been in a lot of hotels. And I like to take radio with me. So I like to have small radio, and I like to operate on most bands. I've put in basically a little bit of my history so you understand why I sort of developed this attitude to operation. In Afghanistan, I also did quite a bit of EMI too, Earth, Moon, Earth, which was good fun. What can be achieved with small equipment, with hotel rooms, with not very much antenna wire, with not very big radios? Well, in March this year, I did a good trip going through a number of European countries, Bratislava, Vienna, Poland, Warsaw, etc. And I ran most of the time 20 meters down through to, or 10 meters down through 160, and also some 630 meter operation. I did do 630 meter in Friedrichshafen last year after FDIM, and I also did 630 meters in Vienna, sorry, not Vienna, in Geneva last year, where I stumbled on a very interesting propagation and antenna system. Okay, so what can we do? There's Dayton 2 years ago, where I had an antenna out of my room at the Clarion Inn Hotel. And as you can see, I deal with Whisper mostly because in the UN, it was something that I could set and forget. I didn't have to sit down in a microphone all night and log and etc. Whisper logs itself and the computer runs it. So it's convenient for me in the career I was doing. And as you can see, over the few days in Dayton, I did 523 spots out of the hotel room. And that was just on a small piece of wire, probably about 5 meters or so, just with a sinker thrown into the tree. Vienna 2 nights last year, as you can see, quite a few spots. Prague this year in March, 2,269 160 meter spots overnight, one night, just the darkness hours. And you will see here the tree, my wire goes out across there and just into the tree outside the window. So it's possibly 7 or 8 meters of wire. And on 160 meters, that's 5 watts and a lot of spots. Now, what are some of the criteria? Oh, and that's the antenna tuner that I used. I don't know if you remember my variometers from the first time at Dayton, but I do a lot of printed variometers. And this one is variometer done with 4 windings on the rotor and stator so that they're the same size. So if you've got the same geometry of a variometer, you get better cancellation and better adjunction. Early in the peacekeeping missions, as I said, I would use voice, but when Whisper came along, it was very convenient. I'll go through this preamble fairly quickly because it was in last year's presentation and I've reproduced some of it for this year so that those that weren't here last year at least know what's going on. I'm very early Whisper adopter in April 2004. So I've been doing it for a fair while and I've been doing it from a lot of locations. What do we need for successful operations? We, of course, need atmospheric conditions. We need to understand the time, the propagation time, distance, location, frequency, as you all know. We need a suitable transceiver and power supply. We need an antenna. And, of course, we need a radio and connect it up with the feed, the power supply, the antenna. I'm going to talk about a lot of the issues of feeding an antenna, a little bit about the radio. I will give Hans's radios an unabashed plug because FSK production on QRP Labs radios is far more decodable than any SSB generated or any SDR generated Whisper signals. We need a proper operating strategy. Okay, with the exception of the first factor, conditions, we can control those other factors, but we can't control conditions, that's clear. So how can we maximise? Of course, one issue is licensing, whether you're allowed to operate in these places. And most countries like us, like US, have the CEPT endorsement, which allows us to operate in Russia, in Europe, Australia, whatever. Oops, sorry. Weight is a very important factor when you're traveling. And you can't take huge lengths of wire, you can't take huge antennas, etc., etc. Batteries, obviously small batteries, and lithium batteries are very good for operating small radios. You get quite good. And I tend to use a couple of phone batteries. Being in Bishkek, there's not a lot of equipment shops around there, so you have to adapt. And one of the things that I do is I buy either phone batteries or the iPad, tablet batteries, put a 2S controller and put the 2. And they're relatively light and easy to carry. And that'll give you 8.4 volts peak when they're fully charged down to, 7 point whatever volts. And they're actually a very good source and low noise. Having plugged in power supplies are great, but they do make a lot of noise on the receiving of the radio. Okay, the radio, as I said, the unabashed plug for Hans's radios, they work very well. And as a consequence, I've worked with Hans on some of the work in the radios. I don't know if anybody knows what a really weird Twisted Sisters transformer is, or a weird Twisted Sisters transformer, but they were part of my innovations to get slightly better operation out of them. The other thing is the little QTH doesn't look like a radio, and especially if you've got an SMA connector on it, it just looks like something to do with computer with Wi-Fi. And so customs and airport security and other things like that are an important factor when you're taking all these through, especially certain countries, such like the UAE, Qatar, Middle Eastern countries, Russia, of course, and other countries. Having something that doesn't look like a radio is very useful when you travel. And I talk about that because I was a customs officer as well. So I understand the roles. Okay, power supply, as I said, small batteries are very useful. At home in Bishkek, I use a pair of 30,000 milliamp hour phone charger batteries, like power banks, and I connect directly to the 2S control board directly to the LiPo batteries. And believe me, you want to be very, very, very careful when you do that, because 30,000 milliamp hour battery either shorted or burned with soldering iron is not good for your health. It really is. And indeed, I use polished shoes in it because that's very important. You need to protect yourself. I don't carry those when I travel because they're a bit heavy, and there are rules on the amount of milliamp hour batteries that you can take on an aircraft. Computer, I use Pi 400. It's got a keyboard in it, a tiny, tiny little screen, and you can run that with a power bank if you have to. Antenna. All my antennas, I use wire wrap wire. Why? Because it's thin and light and you can't see it when you put it out. Especially if you've got a blue wire and it's bright sunshine, or white or grey wire when it's dark and whatever. But the important thing is wire wrap wire is also a little, you can leave it if you have to. If you lose it, don't cry about it, because you can buy 300 metres reel of wire wrap wire for next to nothing on AliExpress, although gentlemen who live here are going to pay more. It's not an issue. I carry small fishing reels with wire already wrapped on it and links that I approximately know what's there. Okay, my antenna launcher, of course. Antenna launchers, because you need something that you can flick that sinker and wire wrap wire into a tree, over a roof, wherever, into a power pole, oh no, yes. And I will talk about that. I do that. The wire wrap wires, I keep certain lengths on it, and a counterpoise reel wire that I hang down as a counterpoise sometimes. Antenna wire launchers, you can buy collapsible fishing rods, and it's actually not a bad idea to have the fishing rod and the sinkers in the bag, because people look and go, oh, fishing, he's a mad fisherman. Doesn't matter. Nothing to do with radio. Oh no, they don't look for radios. As you can see, I've done the plastic 3D printed slingshots because in Australia, they have quarantine rules that you have to declare and show any wooden items from a quarantine point of view. So it's better to have a printed slingshot, and you can say, oh, no, it's a plant carrier or whatever. It's not a weapon, and you don't leave them assembled. Okay, that's my favourite one from Bratislava. Nice little pole, and there's a couple of fishing poles. And of course, where I live in Bishkek, a former Soviet state, fishing is, people love fishing. So there are a lot of Chinese collapsible rods that I can get in Bishkek for about $7 to $10. It's great, as Mitch will know. Antennas, just get as much wire out as possible. The more wire you've got out, the better the antenna will be. And don't tell me, oh yeah, you need exactly 9 metres, whatever, for 40 metre or whatever. I don't. I get as much wire as I can get out with a slingshot, and then I have my tuners. And of course, sometimes it's good to hang a wire down the front, just making a wire down. And in fact, I've actually used a fascia wire as an antenna itself, and I've got it out, no problem. Now, these I got in Taiwan, although they're more readily available, and they are the releasable type of cable ties, and they're great for tying the fishing rod to balustrade, to you know, balcony rails, etc. But don't carry them in your hand baggage. Why? Because they can be considered as handcuffs, and security don't like them in aircraft. Okay, an antenna tuner. That is a great antenna tuner, but it weighs about 3 kilograms. It's no good for travel. And also people look at it in the baggage and go, what's that? Okay, years and years ago, I started doing SED matches. I like SED matches. You can get very good tuning with SED matches. But one day I took my best SED match, this one with a T68 6 toroid, and I compared it with just a straight LC. I calculated the L, I calculated the C, used an air-wound inductor and a small polyvaricon. I put it on the antenna, the Z match, didn't change anything, measured with and tuned it with the digital storage oscilloscope on the wire, left the probe on, measured the voltage, then swapped to the LC match. And the LC match gave twice the RF voltage on the antenna. So what does that tell me? It tells me that this little device is consuming half the power. Because if you've got twice the voltage without it, it's 4 times the power out. So why would you bother have toroids? So from that point on, I used wholly non-ferrite, non-iron powder antenna inductors. That was my first attempt at a variometer. Winding on a ping pong ball is not easy, I tell you. But what I did was I got double-sided tape, put it on the ping pole, and then got the thing in the right place, and then lashed on the super glue. And it stayed in place, and it worked. It worked quite well. So variometers, I love. Variometers are really, really good. There's some nice variometers tuners that I've made, but even this one is very heavy. We're talking portable. We're talking about taking everything you need where you can't get things. So these are 3D printed variometers and tuners. I've done dozens and dozens of variometers. Anybody remember all my table of variometers? The first FDIM a couple of years ago, and last year too. Okay, now, coupling and tuning matching accessories. These are extremely important to get the best possible signal out there. This one is a Wheatstone bridge with the antenna on one leg, your 50 ohms on the other balanced side, and then an LED and a reverse connected diode that will show the balance of those two resistances. And that will give you, it won't give you SWR. It's not an SWR measurement, but it will tell you that you've tuned that antenna close to 50 ohms. And the other important thing on that, of course, is this, which is an LED on a toroid, 4 windings on a toroid. The antenna wire goes through the toroid, and the LED will light up or dim if you've got more current or less current. The more light, the more current. And if you've got an antenna wire out there, is more current in the wire better or not? It is. It's a simple technique. The more current you can have out in that wire, the better you are going to get out. Here's another version of that, and this is actually sitting in the hotel room at the American Extended Stay America Suite Hotel, where I've got a tiny little toroid, a germanium diode, and a meter. And you can just easily tune the antenna tuner. Once you've found the balance point on the LED Wheatstone bridge, you can go to the current measuring device and just tune for maximum current on the antenna wire. So I've done lots and lots and lots of 3D variometers, and they are all good. I made LC matches, but then I came across an amateur's page, PO0FRI, and he had the free match, which is a modified version of a Z match. And how many people are familiar with a Z match? You've got an inductor, a small inductor, a tap, a larger inductor which tune, and an output winding. Z matches work very well. You can use them on a broad range of impedances. And I've made dozens and dozens of free matches since I came across that. There's a circuit diagram which was notes which is equally good for generating a free match or a Z match. Whoopsie daisy. There's some of my free matches. And I've got many, many, many more at home. And I've got a bag full here that you'll see tomorrow night at the home brew, etc. This is probably my favourite Z match, free match. And as you can see, it's not very big. It's about 8 or 9 centimetres square and about the same height again. And it's relatively light. And what is important about free matches is it's low to high, or you can turn it around and have high to low in impedances. So it's actually, if you don't get a tune one way, turn it around, then you get a tune the other way. It's easy. Very important to know that they are reversible to match high to low or low to high. Very important. Now, let's discuss HF, below HF, because that's what I want to talk about today. 160, 630, 2200, and another thing. We will look at another frequency. And one of the things that I did was I found out that I could do multi-twisted pairs on variometers and get much more inductance. One of my large variometers has 5 windings on the stator and the rotor, and I get 50 millihenries inductance out of the peak by seriesing all the wires. And that's only a 124 millimetre diameter variometer. And the Litz wire is equally as good for free match or Z match configuration. Here you see 30 strands of 0.2 millimetre wire. What I do is, one end I split into 6 bundles of 5 wires each, solder them together, then I go to the other end, and with a multimeter on noise, I find which are the matching pairs to the other end. And so I then have 5 or 6 windings that are very, very closely coupled together, very good balance, very good inductance, because you know that if you have 2 windings on the same configuration, it's 4 times the inductance of the original. If you've got 3, it's 9. If you've got 4, it's 16. If you've got 5 windings in the same thing, it's 25 times the inductance of the original winding. Are you with me there? You all understand that? Very simple. You're just seriesing inductances, but on the same actual winding. It's like you have a winding with 100 millihenries, but it's that microhenries, but it's that big. If you've got twice that number of turns in that, it's 4 times, and so on. So Litz wire is very useful for making up high inductance. And the other thing that's good about the Litz wire is very, very closely coupled between every wire. So if you've got, if you go back to LT Spice from Nick, and look at the coupling factor, you can look at 0.99 and not 1, because we're not perfect, but it's a very high coupling coefficient for the windings. Okay, I've now started doing 2 different implementations of both the conventional and pre-match. Instead of just an ordinary toroid making the 5 turns, 5 windings in a series around the toroid, I do 5 wires on the same variometer. The only thing is it makes it very narrow frequency usually, very narrow, but very, very high Q. Here's an example of one of my variometer tuners. That one is for 630 meters, right? It's not big, it's about that big. And it works on 630 meters. And I can get tuning on 10 meters of wire. Well, 10 meters of wire is 1/630th of a wavelength. It's tiny. And it's light too, it's not heavy. There's a 2200 meter tuner. You see these are just standard 450 plus 450. But see, the thing is only, that big. It's not huge. And when you consider 2200 meters, it's a tiny length of the wavelength of a thing. And that works very well. Here was my first spots on 630 meters in Europe. That was Friedrichshafen last year. It was 17 meters of wire out the window to a tree. And yes, it's only 30 or 40 kilometer spots, but that's from a hotel room. It's not from a huge antenna. There's another implementation that I've done. I've got, again, the Litz wire there. I've split it up into your 4 windings for the one side, and then the 1 or 2 windings, because you can have high or low impedance on the output. And you can see the tune on that is pretty damn good. Nano VNAs are great, aren't they? And they're light. See the tune as I'm moving it up and down? It tunes well, it really does. And the strategy with tuning a Z-match is you tune the tank coil to the best frequency, and then you tune the load capacitor to get the best transfer of the power between the device, etc. Okay, now I'm intending to go on 8900 Hertz. I was going to bring an 8900 Hertz station here, but I ran out of time to finish it. That particular toroid is 15 centimeters in diameter. Again, it's 6 windings, Litz wire. That takes a bit of work because you're working with 0.2 millimeter wire and you're finding and you're measuring and you can get awful confused doing it too. But that particular toroid is 3100 microhenries, 3.1 millihenries. And it's not a rubbish bin this big with lots and lots of wire on it. You can't carry them in suitcases. They just don't work. Now, for the 8900 Hertz stuff, it's very simple. You go on eBay, you get a Bluetooth speaker amplifier that'll work on 5 volts and put out 5 watts. You use, how many people here know about WhisperWatch program? Anybody knows WhisperWatch? WhisperWatch is written by a friend of mine in Australia, Peter Marks, PK3TPM, and he's got a whisper generator in it, and he, instead of running 1500 or the tone you want for whisper, you put on your 8900 Hertz, and then you just amplify it with the audio amplifier. And bigger, you've got an 8900 Hertz transmitter. And with this, I can make an 8900 Hertz Z-match that will tune most things, except I need a couple of hundred nanohenries of capacitance to tune it. Gosh, anybody got any one or 200 nanohenry variable capacitors in them? No. So what do we do? And that's the same thing. That's a 2200 meter tuner Z-match. And the little toroid is only about that big. It only is about 140 microhenries. But again, great tune. Now, I did that spots, a couple of my tuners, and you can see really nice. And there's an example. That's the nano VNA, and you can compare the size of the tuner with the nano VNA. Not big, is it? And it's not heavy either. And it's all plastic, so it doesn't show up in X-rays. Very important. Okay. The biggest stumbling block, as I see, low QRGs are the size of the capacitors. So what do I do? I go to the spreadsheet, calculated the capacitance of series capacitors in various steps, and then calculated for another capacitor to interpolate those steps with smaller steps. So I got fine tune and coarse tune. Now, the design of the series, etc. Hans did a lot of work on pin diodes and QTHs and QMX, etc., and QMX plus, and they work really well. But pin diodes don't work below about 1,000 hertz. Below that, they start to rectify the signal, so you get third harmonics all over the place. So what do? We use the switch capacitors. Whoops, wrong. Yeah. Okay. This is a switch capacitor with a row of pin diodes. And basically, I've calculated the capacitance in series, and the pin diode selects the capacitor. That's fine for HF, for 1.8 to 6 meters, right? That's not going to work on our on 8900 hertz, for instance, because you need a giant capacitor for that. This is, why isn't this? Oh, sorry. Right, that's another version. The important thing about this one is it's 2 pin diodes in series back to back to reduce the amount of parasitic capacitance. Because 2 together means you get at least half the series capacitance of the 2 individual diodes. And when you've got 10 or 11 diodes in parallel, the capacitance can be quite high, and you can never reach a 0 picofarad. So this helps the back-to-back diodes. And of course, the other thing is you have the back-to-back, but you have another set of diodes which at the output, which is turned on for when everything's off, but you turn it off when you want 0 capacitance. Okay. Oh, I can't spell. Otto equals opto. Sorry. I've just started investigating the use of opto-isolated triacs to replace the pin diode switching at lower frequencies. I mean, opto-triacs are basically designed for light switches and that sort of thing, but they work on RF. They don't work very well on HF, but as you go down lower, it works better and better. And here is an opto-isolated switch. I tried these, and I had basically, I've got a capacitor, then a T capacitor with those 2 in series, and then switch to the actual output capacitor. And then the next one adds another capacitor and another, and so on. So you can calculate out the switch capacitor sequence. But here, a 40-meter signal of the spectrum going through no triac and through a triac turned on. And as you see, without the triac, it's about 65 dB. With the triac, it's a bit over 40 something dB. But as you go to 160, 2200, 89, the amount of distortion decreases fairly well. So I should be able to have a 220 nanofarad electronically controlled switched capacitor, which means I can have an auto tuner just switching the capacitors correctly. And as the means of selecting, telling the computer what to do, is instead of using a Wheatstone bridge with just a diode, etc., I put an opto-isolator as the switch as the diode in the Wheatstone bridge. And if you think about it, if you can do it manually and think about how to do something manually, you can tell a computer to do the same thing. And of course, opto-isolators tend to use infrared diodes, so they have lower switch on voltage, so they get better sensitivity. Okay. Opto-isolator, so there's potential for using these in HF, but low HF, but I've got to work on that. Now, there's my 2200 meter Z match with manually switched capacitor and just an ordinary small, like large step, small step. And you'll see there, it's not very big. It's about 20 centimeters long and about 19 or so wide. And it's a lot lighter than that kitchen chopping board and two giant, two nanofarad capacitors. And of course, that's the 630 meter Z match. Again, you can see it's about 18 centimeters square. Very light and of plastic and does not show up in X-rays. In Geneva last year, I found a very interesting way of getting out. I found that my room was there, and these are high tension 400,000 volt power lines. I had my wire out of that into the tree. From there to there was 14 meters. So I had a 14 meter long wire on 630 meter wavelength. Tell me how that works. So I assumed, and I tested again, that I was coupling into the wires. And I knew I was coupling into wires because I was getting shocks off the antenna wire. Now, this is why I say you need a Z match, because a Z match has an earthed output transformer winding, which means you're not going to be poking around and killing yourself or blowing up the rig with, 100 kilovolts or whatever. But I got spots to England, the north of England, on 630 meters, 14 meter antenna wire and 5 watts. How does that work? So clearly I'm coupling into the wires. And Hans and I are going to be doing quite a few more experiments on coupling in local wires in Dalian and seeing just how much we can get out of it. But so this means, as a possibility, doing a couple into an AC wire in a building and using the whole building's wire as an antenna. Will it work? It will with a Z match, as long as you've got it isolated. Okay. And those were the spots I got from the high tension coupling. Now tell me how I'm going to get 1200 kilometre spots on 630 metres if it wasn't coupling into those wires. Anybody give me an explanation? I don't think so, I can't. And there was another day, that's when I found out, that's the first one I did. Whoops. And that's, wait. Oh. Right, that my tuning coils for the 34 kilometre wavelength whisper signals. I'd hope to have it ready so I could put the transmitter here and the wire down the back on batteries so that you could not accuse me of running wires through the thing. But I believe next year I will be able to demonstrate properly a 34 kilometre whisper station. No spots on 2200 or 8900 yet, but even 160 is difficult to get spots on. Anybody do regular 160 metre spots with 5 watts and 10 metres of wire around here? No. Any questions? Please.
I know you're talking about coupling low power levels into your hotel wiring.
Yep.
I also know that ham radio operators are not dummies, but I'm pretty sure Hans should start working on that obituary again. And people need to understand how incredibly dangerous 400 kilovolt power lines are.
Especially when the power lines are 2 meters above the antenna.
Well, that would be death instantly. But the thing about coupling a signal into a wiring of a hotel, you potentially are going to damage other people's equipment. You're going to take their computers offline. You're going to take the servers in the hotel offline.
No, not with 5 watts.
Probably not, but I don't think it's a wise activity. Lastly, you should check to be sure it isn't illegal in each of the countries you want to do it. Is it maybe that intentionally coupling an RF signal
certificate? I'm not worried.
to the power? No, can't deal with it. Sorry.
Yeah, no, this is just an experimental view on things. Okay, next question. Yes. Remember, as amateurs, we all push the boundaries as much as possible, don't we?
Dennis, WR4I. I have my whisper transmitter on 24 hours a day.
Yep.
200 milliwatts.
Yep.
And I'm hitting all kinds of things with untuned G5RV on all the bands except 160. The question is, when you travel, are there CEPT requirements for a whisper transmitter?
For each?
Are the countries requiring CEPT for a whisper transmitter?
No, I take my QMX Plus with me. I've got all bands.
Right, but you know, when I travel and I take a transmitter, I have to look up to see what the regulations are for me to do CW or sideband and that.
Oh yeah, sure.
For these whisper transmitters, is there any requirements for that?
Not really.
No.
No. It's a digital mode. There are requirements on 60 meters, for instance, channelization and EIRP, but with a 5 watt whisper transmitter, you're not exceeding any EIRP. I did 100 milliwatts from a hotel in Abuja to Penryn Atoll in the middle of the Pacific and spots. But it was with a Z match and a fishing pole and a hanging wire.
My question is, I don't use Whisper, don't know anything about it, but when you go down to those experimental low frequencies in the audio range, who's got receivers to hear those so you can
I've got a receiver. Yeah.
Huh?
I've got receivers for all of them.
I mean, around the world, when you get those spots, somebody's receiving those.
And
on those low frequencies.
Yeah, but don't forget, below 9 kilohertz is not regulated anywhere in the world.
I don't mean that. I mean, who in the world has a receiver turned on to hear it at those frequencies? That's my thought.
If you bothered to transmit right at the moment, my whisper station in the hotel would receive you on 630 meters.
Okay. So there's a few out there. So yeah.
And if you look at Whisper Watch and look at the number of stations and the number of spots on all 2200, 630, 160, there's loads of people on, loads. Next.
Since your wire was 90 degrees to the power lines.
No, it wasn't 90, it was sort of at a,
Oh, okay.
an angle. But
So,
the end of it was under the wires at about 2 meters, 3 meters.
okay, gotcha. Because I was wondering if it was a weak coupling and if you had it parallel, there'd be a
It was,
stronger coupling.
I mean, think of it as the match, the stub match on a Yagi. I don't know, but there's evidence that it works. You don't get 1,200 kilometre wire on 14 meters of wire. You don't get 1,200 kilometre propagation. Very rare. And I received on it too. I will be bringing virtually all of my Z matches and free matches and things tomorrow evening on the table, so you'll be able to see them. And they're really light. I mean, I've got 36 kilograms of baggage, and that includes a whole lot of stuff, radio stuff for this. Anybody else?
Good afternoon. Thank you for such an interesting talk. The first time I ever had an HF receiver, and I had just gotten my technician ticket. Kind old fella put an old Heathkit receiver. He offered to send the whole thing with me, but I'm like, I can't use a transmitter. I'm not going to take that. And we stapled a bunch of 22 gauge wire to the ceiling in our apartment.
Yeah.
And it was incredible what we heard. And then we tried hooking that to the downspouts in the apartment complex. And then we started putting wire all through the parking lot. And then it got wrapped up in the car tire. And it's a good thing I didn't screw it to the back of my new friend's receiver, and off it went.
Well, that's
I love the spirit of what you were doing. My question is, and pardon me if I missed this during your talk, when I'm looking at all those crazy toroids that you put together to make a lot of this happen, I swear those look like either plastic or 3D printed, the form that you've got the wire.
3D printed.
Wow. Okay.
Everything is 3D printed.
I can't wait to visit your booth when you bring all the toys.
Yeah, have a look.
Thank you very much.
You're welcome. Anything else? Come and look at the stuff tomorrow evening. I've got most of that stuff there, and I've got some little tuners that are that big, and I've got the bigger tuners, and I've got the, I mean, a couple of years ago in the FDIM 2023, I had quite a few of the large toroids, etc. One large variometer. The large variometer I had was 124 millimeter in diameter. Its peak inductance was 1.8 millihenries, and its lowest inductance was 11 microhenries. So you had 180 to 1 in ratio, which is enormous. And the reason why is because the stator and the rotor were almost exactly the same size. So they were almost exactly the same inductance. So you get maximum addition, maximum cancellation. Okay, thank you.